So there's 3 different ways you can do simultaneous equations, and this is the first one, which is graphing. So with graphing, you want to do it as accurately as you can. So we've got 2 lines here. We're going to try and find their x and y intercepts and then graph them. So y-intercept is generally easiest to find because if you're in mx plus c form, because when you sub 0 in there, it's just the number on the end. We know that. And then for our x-intercept, we need to do a little bit of rearranging. So we minus 1 from both sides, divide by 2. It's good to practice our algebra every now and then. Alright, so that's our first line. We know our x-intercept is at -1/2 and our y-intercept is at 1. Then if we can manage to draw a straight line, which doesn't always work, we can connect them up really accurately. So there we go, nice straight line. Then we do the other equation. So as you can see, this takes a little bit of time and you have to be accurate, otherwise it will not work. Alright, there's our y-intercept and our x-intercept is going to be, take 4 from both sides, divide both sides by -1. So there's our x-intercept. So we can plot those. Once again, make sure it is a straight line or you will not get what you want. Oh, it just doesn't want to draw. There we go. Alright, so here we can see I didn't actually manage to do that perfectly because the point of doing simultaneous equations is to get that point of intersection. The point where 2 lines cross over and have the exact same x value and the exact same y value. Mine isn't accurate enough because it should be there at 1, 3. But mine's a little off. Hopefully yours is more accurate when you do it. So as I said, the first method, bit clunky, not the biggest fan of doing it by graphs, but luckily we have these 2 other methods to try and find that point of intersection.